Welcome to my channel Living Linux. In this video I want to show you how to build DuckDB on RISC-V. Now I have to mention that there is no official RISC-V support, so this is not supported by the DuckDB team, and you can say that you can use it at your own risk. But the reason for me to try this is that I see quite often that people say like, well, RISC-V, come back in 10 years, it's not really usable now, and there's not that much software available for RISC-V. So, as I also showed in my earlier video, where I compiled the game Endless Sky on RISC-V, that when the source is available, then at least we can give it a try. So now the reason why I tried to compile DuckDB is that I saw this post on Bluesky, and here they said not on RISC-V. So that's where I thought, hold my beer. Well, actually I don't drink beer, but I thought, challenge accepted. And well, this person is a good sport, because once we showed that it is possible, he replied with amazing. So now it wasn't really that easy as it is to compile it on x86 or ARM. So if you go to the DuckDB website, you can go to installation and then more installation options. So you saw that for x86 you can just download a package and then immediately start it. But of course that's not available for RISC-V, so at least they give you the option to try to build it from source. So you have to install some packages, and from there you can clone the repository, and then in theory this is the only command that you need to build DuckDB. That is true on x86 and ARM, but not on RISC-V. So first I was trying to mess around with CMake list, but then probably some extensions they don't get built, so that was not a good option. And I also tried to find some help on Reddit, and luckily there was someone that got it working by adding the architecture string and adding the needed extensions. But as you can see here, that the SpaceMate chip, it actually has a lot of extensions. I think these first are, let's just say, general, so they're not really extensions. But you can see that there's still a lot of extensions. So yeah, if you have to add that to the architecture string, you can get a very, very long string. So yeah, just as a side step, one of the things to counter that is profiles. So there are multiple versions. And you can see that, for instance, with the RVA22 profiles, they say like these are the mandatory extensions, some more, and you can also have like optional extensions. So, but if you can work with the profiles, then hopefully you don't get this very long string to mention all the extensions. So once you have the repository and you go into the directory, then you can try to build it like this. And actually I added the core extension FTS, full text search. There are more extensions, as you can see here, so you can make a list separated by semicolons, but it's hit and miss, because actually I also tried it in a different way. They have a separate section for building extensions. I also tried it with a CMake configuration file, and I got an error on inet that the directory wasn't there. So yeah, I'm not really sure why that is, but just as an example, I only went with FTS. So yeah, there was one other thing, and that with the way they have their build system, you don't control the amount of threads. So by default, Ninja just counts your cores. So in the case of the SpaceMid, that is 8 cores, and then it adds 2 more. So you get 10 threads in total. But the thing is that you also need memory to be able to work with 10 threads, and I only have 4 gigabytes of memory. And yes, it's possible to add swap memory, but that usually, yeah, it's not the best option for speed. So yeah, also in the Reddit thread, they tried to help me with that, and where was that one again? Here. So you can try to do it like this, but then yeah, that gives an error on my system. So let's just say if we try that like this, so then it needs the build.ninja file, and it's not here. So, but I used, you could say, sort of a dirty trick, because with Linux you can take CPU cores offline on the fly and also bring them back online on the fly. So let's just say we have 8 CPU cores, as you can see here. Now there is a way to take them offline, and when you want to take them offline you have to change this to 0. And yeah, just to show you where I got that one from. Yeah, I got this one from here. Because I'm not really that smart, but I know how to use a search engine. So if we go back, so here we see 8 cores. Now, if we execute this command, we count starting from 0, and with 8 cores you can go up to 7. So in this case we take the cores 1 through 7 offline. And here it says, here it starts from 1, but this command starts from 0. Okay, so now the system monitor is a little bit confused because it didn't really notice that. Oh yeah, it did notice that the CPU cores are now offline. So once you've done that, then you can start the build, and once it's building, so let's just say when you see like 0 out of 700 something or 800 something, that's where you know that it already decided on the amount of threads, and then you can just bring them back online like this. And now you can see that it notices that all the 8 cores are available again. So let's just say we want to test the build of DuckDB. So here it is. That's just the prompt to execute your SQL. So let's just say, I have to say that the documentation is actually quite good because they also have examples. So we've built the FTS extension, and because we specified it during the build, then you don't need to install and load it, it's already there. So here they say that there's an example, so we copy this and then we add it like that. So this has created a table and it populated, I think, 2 records. And then they say build the index. So not that much data, so that goes quick. And then they say this is how you can use the FTS extension. And we get a result. So the only thing is that I get a different score. Not really sure if that's correct or not, but in itself the FTS extension does seem to work. So the only thing is that perhaps with the score I'm not really sure if that is correct. And here they have another example command or SQL statement, and it also works. So yeah, again, Yes, RISC-V is a relatively new architecture and software support is very limited at the moment, and as you can see that sometimes the developers, well, they haven't really tried building it themselves on RISC-V, so they don't even know if it is possible to run it on RISC-V or not. So even if it is possible to build it, that doesn't automatically mean that you will get support for it. But what I'm trying to do is just show people what is possible, and of course there are probably plenty of applications that where it simply is not possible to build it, or that you have to do a lot of tricks to get it built on RISC-V. But I think the programs that are developed in a way that they don't really rely on sort of like really directly banging the hardware, then there is a reasonable chance that you can get it compiled on RISC-V. So I think that is the good news. So looking back, we have compiled a game like Endless Sky, and earlier also like Stable Diffusion with On Extreme, and now we have, well, what I would call a serious application like DuckDB. I mean, so far I wasn't able to get all the extensions compiled, but I think we've made some good progress, and now that the DuckDB team knows that it is possible to get at least DuckDB as a base program running, then perhaps that they will also, hopefully in the near future, will consider supporting RISC-V. So this is all for now, and I hope to see you again in my next video.